Hello, this is Dave Birmingham. Today I'd like to demonstrate how SteelEye DataKeeper Cluster Edition can facilitate live migrations of Hyper-V virtual machines across data centers. Okay, so let's jump right into this demonstration here. What you see in front of you is a Microsoft Management console. I have a few snap-ins here. I have the SteelEye DataKeeper GUI snap-in. I have the Hyper-V Failover Cluster Manager snap-in and a Hyper-V Manager snap-in, as well as a few other snap-ins. So first, let's take a look at SteelEye DataKeeper. This SteelEye DataKeeper is a host-based block-level volume replication solution. It can replicate any volume from any server to another server, regardless of the storage type. So, in this example, I have an F drive that is currently being replicated from a server called Hyper-V1 to another F drive on a target server called Hyper-V2. These volumes are just some local attached disk in the server, but they could very well be iSCSI targets or fiber channel SANs. As long as it appears as a local drive to that server, we can replicate it from one server to another. Okay, so I've configured that mirroring. We can see that we have the mirroring going on. We can see the mirror type is asynchronous. The disk space and compression and bandwidth settings, all in the DataKeeper GUI. So now let's jump over to the Failover Cluster Management GUI, and I have pre-configured a virtual machine resource. We called it Replicated VM, and we can see that the current owner is Hyper-V1. And in this resource, we see the disk drive is now a DataKeeper volume. So this actually replaces the shared storage, which would normally be presented as a physical disk resource. So we're replacing the shared storage physical disk resource with a replicated DataKeeper volume resource. So if I take a closer look at this DataKeeper volume resource, I can see that we have custom properties, DataKeeper properties. So we see that it's the F drive. We see that the source system is Hyper-V1, the target's Hyper-V2, the address that is communicating across mirror state and the mirror type. So all that is displayed right in the failover cluster GUI. So let's go ahead and we see it's running on Hyper-V1. So if we look at Hyper-V Manager, we see this replicated VM is currently running. Let's go ahead and open it. I have Notepad opened inside that VM. So we'll just put a little note here, say running on Hyper-V1. Okay. And let's close that. And we will now initiate a live migration. So through the failover cluster GUI, we will click on the virtual machine resource and we say live migrate virtual machine. So we're going to live migrate that virtual machine to Hyper-V2. So go ahead and click that. And that initiates the live migration. And we see the status in the failover clustering GUI here. We can see the percentage complete. And we see now it's currently 13% complete. If we go to the Hyper-V Manager, we still can access that virtual machine, and we can still work in this virtual machine. So we are now live migrating. So the virtual machine is still available. This is the big difference between live migration and quick migration, where quick migration, during the migration process, the virtual machine would be unavailable. So Microsoft previously would pause the virtual machine, would write the system memory to disk, and then switch over the disk and read the system memory from the disk and restore the virtual machine to a running state. So that there was always a period of downtime of anywhere from 10 to 20 seconds during the switchover period where the machine was unavailable. Instead of writing the virtual machine memory to disk in a live migration, it's actually synchronizing the in-use memory of that virtual machine between the two servers. So now when we do the switchover, we don't have to read the memory from disk since it will already be synchronized. So there'll just be a split second when the actual switchover occurs, where we reverse the drive letters, reverse mirroring for the F drive, and let's see, the live migration is now going completed. So we have we had the second in between where the machine actually went from Hyper-V1 to Hyper-V2. So we go to Hyper-V2, we see now this machine is running over here. We still have Notepad up and running, and we'll say now running on Hyper-V2. And because the volume is now being replicated back from Hyper-V2 to Hyper-V1, we can simply switch back to Hyper-V1 whenever we're ready. And we can see that's reflected not only in this Hyper-V DataKeeper volume resource here. We can see the properties. We see that the source is now Hyper-V2 and the target is Hyper-V1. We also looked at the DataKeeper GUI. We can see that the source is now Hyper-V2, the target is Hyper-V1. So let's go ahead and migrate this machine back to Hyper-V1. So we're initiating a live migration back from Hyper-V2 back to Hyper-V1. So it's going to the process of synchronizing the memory state between the servers. Once that is in sync, the volumes will switch over, the mirrors will be reversed, and the machine will continue in its current running state. This whole process takes a little bit longer than the quick migration previously took, but the benefit is there's no apparent downtime to the end user. So even though it takes a little bit longer to synchronize the system memory versus just flushing it to disk and reading it to disk, the actual downtime is eliminated in the live migration. I'm going to pause this and continue when we are on the other side. Okay, the live migration has completed, and you can see that we are now back running on Hyper-V1. The DataKeeper volume is now replicating again from Hyper-V1 back to Hyper-V2. Hyper-V Manager, here's the running virtual machine. So we are now back on Hyper-V1. So that concludes my demonstration of SteelEye DataKeeper Cluster Edition, working with Windows Server Failure Cluster to do a live migration of a Hyper-V virtual machine from one data center to another, eliminating the requirement for shared storage.